Our group chose to present on the Loma Prieta earthquake of 1989 south of San Francisco, California. The earthquake occurred at 5:04 p.m. on Tuesday, October 17, 1989, and lasted 20 seconds. The epicenter was located 56 miles south of San Francisco on the San Andreas Fault Line, which falls on a transform plate boundary. The San Andreas Fault Line had not had an earthquake since 1906, and historic trends predicted that an earthquake was due between the Pacific and North American plates. Scientists made this prediction based on the fact that land west of the fault had been moving northwest 2 inches every year for millions of years. The aftermath of the earthquake was devastating to say the least. 63 people were killed, 3,757 were injured, and 12,053 were displaced from their homes. Citywide damage and business interruption reached $10 billion. This mass disruption of humanity led to the creation of the Seismic Hazard Zoning Program. This program is nationwide and involves the mapping of hazardous zones that have the potential for large, devastating earthquakes similar to Loma Prieta.
In the California Santa Cruz Mountains, this altered the region's natural landscape. Landslides were driven by the powerful earthquake, which caused dramatic changes in the environment and transformed the landscape. Numerous landslides brought chaos and disruption, obstructing traffic and even destroying buildings. But the earthquake's impact did not stop there. Along the San Andreas Fault, a surface rupture occurred which left its mark with offset railways, twisted fences, and altered buildings. Gas pipelines broke, and other circumstances led to fires in specific areas. While not on a global or long term scale, these fires momentarily impacted local air quality and even had regional climatic effects.
These seismic events left their mark on three crucial Earth systems: the geosphere, the hydrosphere, and the atmosphere. In the geosphere, the earthquake's direct influence on the Earth's crust resulted in ground trembling, landslides, and the striking surface rupture that we've witnessed. Moving to the hydrosphere, local streams felt the ripple effects of the landslide and surface ruptures. These changes altered the water's sedimentation and quality. Finally, in the atmosphere, we observed the localized effects of the earthquake induced fires. These fires, though temporary, had a short term negative impact on the air quality, affecting the air we breathe.
Following the earthquake, the shift of the plates caused the Hayward Fault to become inactive and the San Gregorio Fault to become active. These neighboring faults switched seismic activity in a process known as fault switch. Following the earthquake, the seismically weak Embarcadero Freeway was torn down and the historic ferry building restored. The reason for the bridge collapse became clear to Berkeley seismic engineers soon after the earthquake. Sections of different lengths were riveted together, and each swaying at its own frequency, banging and breaking the sectioning connections. The engineers proposed an expeditious and inexpensive fix, but that was blocked by Caltrans, which had jurisdiction over the bridge. The impasse led to a long, tortured rebirth of the east span of the bridge, which finally opened in 2013. Despite this delay, the Loma Prieta earthquake shed light on the weaknesses in architecture and increased research and use of aseismic structures.